Hello everyone, in today's tutorial I'm going to demonstrate how to use the optical pulse sensor with Arduino, measure heart rate or heartbeat, and I'll also be giving a simple example of how to make a heart rate monitor with a pulse sensor, Arduino, and an I2C or LED. This is the sensor I'm talking about. This is the pulse sensor. It is rather a simple sensor. At the front, it has an LED at the front and an APDS9008 photo sensor. That's the front, and this heart-shaped label is where you place your finger, or it is where you put the part where you want to measure your heart rate. At the back side, this has several electronics here. Maybe I'll concentrate more on the outputs. This is the signal output. This is the power or the VCC, and this is the ground output. Then here we have a reverse protection diode, and this is the MCP6001 operation amplifier. Then this other circuitry here is for the RC filter. The wire connections for this sensor are not color coded, so you can use any wires you want, but you have to check and be certain of the connections for the signal, VCC, and the ground. I talk briefly about how this sensor works. This sensor works by shining a green light on the area where it is placed, and then measuring the amount of reflected light with the photosensor. So with every heartbeat, there is a change in volume of blood flow through the blood vessels, which causes a change in the amount of reflected light, which in turn produces a waveform signal at the photosensor's output. So this signal is usually very small and a bit messy. It's not very clear. Therefore, it is passed through the RC filter and then amplified, produce a better signal that can easily be detected by microcontrollers like Arduino. Therefore, before using this sensor, we need to first calibrate it so that we can know which of the signals that are being produced can be counted as a pulse or a heartbeat, because there are usually very many signals output from the sensor. That's what we are going to first look at. So to be able to calibrate this sensor with Arduino, you're going to be connecting it with Arduino. The connection is rather straightforward. As you can see, you're just going to connect the signal pin to analog pin A1. You connect the ground pin to ground of Arduino and the VCC to 5 volts for Arduino. Then let me look at the code that we're going to be using to calibrate this sensor. This is the code we're going to be using to calibrate our pulse sensor. It's rather a simple code. What it does is, remember, we have connected our sensor to the analog pin A0. So what this code is going to be doing is going to be reading the analog signal from pin A0 and sending that code to the serial plotter. Then from the serial plotter, you can be able to check out our pulse wave. Then I've also included this other LED13, that's the onboard Arduino LED that is going to be turning on and off whenever the signal goes above a given threshold. For example, here I'm going to have a threshold of 550. So whenever the pulse goes above 550, the onboard LED will be lighting to show you that is a heartbeat. So we are going to upload this code to the Arduino board, and after that, open the serial plotter. Then after opening the serial plotter, we can now place our finger on the sensor, and then we shall begin checking out the waveform for the pulse. And as you can see here, so you can see the pulse goes up and down, and then you check also the onboard LED goes on blinking, goes on and off depending on the pulse that is being detected by the sensor. Then something else I wanted to note is that now you see most cases the threshold. For example, here, if you look closely at this waveform, you discover that you use the threshold of around 550. So because we are using a 5 volts power supply for this sensor. But this sensor can use both the 5 volts and 3 volts. So if you're using 5 volts, the threshold is going to be a bit high. For example, our case, it is 550. But now I want to change the supply voltage to 3.3. I'm going to be using the 3.3 value of the Arduino, and then we see what happens to the threshold value. I've now changed the supply voltage to 3.3 volts for my Arduino. So now let me put my finger on the sensor and I see what happens to the threshold now. So as you can see, now the waveform is around 300 and 400. So the threshold is around 340, or you can say 340, 350. So that's it. When you use 5 volts, the threshold is a bit higher. When you use 3 volts, it's a bit lower. So after setting the threshold value and calibration of the pulse sensor, we can now be able to use it in our projects. For example, the next project I'm going to be looking at is a simple heartbeat monitor. This is the setup for our heart rate monitor. We are going to be using a pulse sensor, an I2C or LED, and Arduino here. So the pulse sensor, I've already looked at how to connect it with Arduino. The connection is rather simple. Just connect the signal pin to A0, the ground pin to Arduino ground, and the VCC to 5 volts of Arduino. Then yeah, this is our I2C or LED. The VCC will go to 5 volts of Arduino, ground will go to ground. Then the clock pin will be connected to analog pin F5, and the data pin will be connected to analog pin F4. You can refer to the schematic to better understand this connection. Then from here, let me look at the kind of code that we are going to be using for this heart rate monitor. So this is the code for our heart rate monitor, which we are going to be making using the pulse sensor, Arduino, and an I2C or LED. So the code is rather not very complicated, it's not very hard. I'm going to leave a link in the description below my video here, where you can be able to go and check out this code and also try it out in your own project and see if it works properly. Let's upload this code to our Arduino board and see how our heart rate monitor works. And as you can see here on the screen, you can see it's almost showing like a straight line because there's no pulse being detected by the sensor. So let me put my finger and then you see what you observe what is going to happen. As you can see, the pulse waveform will be shown on the display corresponding to the heartbeats, and also the number of beats per minute will be displayed. Normally the BPM should be in the range of 60 to 100 beats per minute. The major challenge of this sensor is its very high sensitivity to movement and infrared radiation. Therefore, for best results, it's better to use it indoors and also place it on hard and still surface. And when you are pressing your finger, you shouldn't press the finger very, very tightly or lightly, because you see, as you see there, the waveform gets distorted. So always be very careful when you are using the sensor. So that's one of the major challenges of using this sensor. That's why we don't recommend such a sensor for health purposes. It's just mainly for demonstration purposes, yeah, and for other projects where I may not need a lot of accuracy as far as measuring heart rate is concerned. I hope you've learned something today. Don't forget to subscribe to my channel and watch my other tutorials. Thanks for watching.